Good morning to all the viewers. I am Deep Kumar Bangotra, working as Assistant Professor in Computer Applications at Government College of Education, Jammu. The topic that I have chosen for today, it is actually composed of three very important buzzwords, very important words in the world of computer science. The words are big data, then cloud computing, and it is followed by smart cities. These are the words, though they are individual words, independent words, but they have a very important relation in between them. So that is why I have chosen a topic: big data, cloud computing, and smart cities. So let me start with the explanation of what is big data. If you see my first slide, here it is a image where you will see that there are many big data. It is actually something which is very huge, something beyond our imagination. It consists of semi-structured data, unstructured data, petabytes, size of data in petabytes, zettabytes, which is people driven, and likewise you can have a look at the image where you will see that yes, it is really very big. That is why it is big data. I am going to give you further explanation of the same thing in the next slide. Now here, according to the definition, what is big data? Big data is not a single market. Rather, it is a combination of data management technologies that have evolved over time. Big data enables organization to store, manage, and manipulate vast amount of data at the right speed and at the right time to gain the right insight. So here in this definition, what we have to keep in mind, there are three important things: that at the right speed, at the right time to gain the right insights. These are the three parameters that are associated with the data that we have to consider: right speed, right time, and the right insights. The key to understanding big data is that data has to be managed so that it can meet the business requirement a given solution is designed to support. Now here in the second definition, big data has the potential to help companies improve operations and make faster, more intelligent decisions. This data, when captured, formatted, manipulated, stored, and analyzed, can help a company to gain useful insights to increase revenues, get or retain customers, and improve operations. Now, further explaining what is big data, you see here that big data is similar to small data but bigger in size. So, what does it mean? It means that yes, we are going to deal with the data, but this time data is very big. Data is in colossal quantity, data is very huge. Again, it has its aim to solve new problems or problems in a better way. Big data generates value from the storage and processing of very large quantities of digital information that cannot be analyzed with traditional computing techniques. So, what is big data? Big data is like, now let me give you a simple example of explaining what it is. It is written over here in this slide, but still, there is another way of explaining the same thing. That is, if you go back to good old days, the scenario was we had our work documented in files. Then there we have one computer operator. He was the person who was doing the job of inputting all the things that were written in the files, in the documents, and he was inputting the things into the computer. So what I am saying, in that case, there was one operator doing the entry of the data into the computer. Likewise, you see there, if there are thousands of operators doing the same job, so that was one case. With the passage of time, what has happened, the job of doing the data entry, it was shifted from a operator, operator, to the individual user. Now it is the job of the user to do the data entry. If I consider myself as a user of Facebook, then what I will do, I am going to register myself. I am going to register myself. So if I am registering myself, so what I am doing the input work. Then likewise, there are millions of users of Facebook. They all are registering themselves on the Facebook. Though this time, what is happening? In the first case, it was the computer operator who was inputting the data into the computer system. In the second case, it is not the single computer operator. This time, all users are doing the job of inputting data into the computer systems. Now, thus we have a shift in the focus from single data entry operator to multiple data entry users. Now, what has happened in the third scenario? In the third scenario, which we are witnessing these days. Now, what is happening these days? It is not the user who is doing the data entry. It is the machines, it is the sensors, it is the GPS system, it is the satellites, it is the cameras. They all are actually producing data. They all are emitting data. When they are emitting data, it is totally beyond the control of the user to input those data into the system. So what is the solution? If machines are emitting data, then it is the machines who will handle data. It is not the user who will handle data. So this progression of data from stage 1, where it was single operator, computer operator, then to stage 2, where the user himself was the operator inputting his jobs, to the third stage, where the data is emitted from the machines, all GPS systems, all air traffic controls, where the airlines are transmitting their status about the altitude, weather, distance to the destination. They all are emitting these type of information, and there is a station at the base where the data transmitted from the Airbus is received. It is just a simple example where I am giving you the instances. If you talk about GPS system, radar system, all these machines are emitting data, and it has to be captured by the machines, it has to be processed by the machine. In the first case, it was one user and one CPU. In the second case, it was, if I say n users, then n CPU. Now in the third case, if there are n machines, now there are n CPUs. In the third case, what we are doing, we are actually seeing a progression in the amount of data generated and progression in the amount of computing resources allotted to compute that, to process that data. This is actually big data, when the data is not controlled by our traditional computing resources. We need huge computing resources to process the data which is generated by machines. So this is big data. If you see this, I have given one example. Walmart handles more than 1 million customers transaction every hour, which is beyond imagination. We cannot handle this type of data on our single PC, on our single computer system. Walmart, you are aware of, we have Best Price, it is collaborated with Walmart. So every hour 1 million customer transactions. Facebook handles 40 billion photos from its user base. So see, the amount itself is very big. That is why it is big data. Decoding the human genome originally took 10 years to process. Now it can be achieved in 1 week because of high computing processing powers available. Now if you have to understand, yes, you are actually looking at the data, and you have to categorize, is it a big data? So it comes with 3 characteristics. If you see 3 characteristics in the data, you can mention that yes, it is big data. First is volume, second is velocity, and the third is variety. These are the 3 things, we call it 3 V's of big data. By volume, you can see here, a typical PC might have had 10 GB gigabytes of storage in 2000. So it is very obvious that long time in 2000, that is 18 years ago, we used to have 10 GB of hard disk in our computer system. And but today, Facebook ingests 500 terabytes of new data every day. See the amount of progression. That was the example I was giving earlier. Boeing 737 will generate 240 terabytes of flight data during a single flight across the US. You see here what is happening. Boeing, an aircraft, is generating 240 TB of data a single flight across the US. How will manage this type of data? A single computer system cannot handle this data. Even if we consider that we have huge storage capacities available, yes, it is true, we have huge storage capacities available in our computer systems. This can be stored there on the single computer system. But the immediate next concern is, if it is stored, can this be processed keeping time constraint in mind? What is the fun of storing this huge amount of data if it is not processed? So that is why other thing is, it has to be processed within the short possible time. Time is a important component here. The third thing, the smartphones which we all carry these days, the data they create and consume, sensors embedded into everyday object, will soon result in billion of new, constantly updated data feeds containing environmental, location and other information including video. The smartphone that we carry with us, it also emits huge amount of data per minute, per second into the system. So this data has to be captured somewhere. You see, you are a Facebook user, you are a Twitter user, you are on Instagram, you are on LinkedIn, you are on WhatsApp. So all these social networking sites, they are actually generating data. It has to be stored somewhere. If it has to be stored somewhere, then what is the fun of storing it somewhere? Ultimately it has to be processed. If it has to be processed, it will bring some results. Those results will be analyzed, and when those results will be analyzed, they will be analyzed to take some decisions. That is the purpose of having big data, then analyzing big data and processing big data. So up till now, what I have explained, big data is something which is huge in size, that cannot be controlled or managed on our traditional computing resources. Now the second characteristic of big data is its velocity. Let us suppose you have your hard disk that contains 1 terabyte of data, 1 TB of data. It cannot be considered as big data just because it is of huge size, because the second characteristic says the velocity with which the data is being emitted and the data is being received at the storage end. Now the velocity is second attribute, second characteristic. Under velocity, we have to see click streams and ad impressions capture user behavior at millions of events per second. When you go through online shopping sites, what do? You shop something, you purchase something. While doing purchasing, you see some ad blocks coming there in front of you. You click on those ad blocks. Knowingly or unknowingly, you click on those ad blocks. Now what happens there? Being single user at your place, chances are that there are millions of users doing the same thing at every second, at every millisecond. The moment they click on that ad block, what happens? It is an impression. It is an impression of user behavior. Either he is interested in that thing or he is not interested in that thing. If the user click on the cross button, it means that the person is not interested in watching the ad. If the user click on the ad, then further information related to that ad is presented to the user. Everything that you do on the internet, it is actually being monitored. Your interests are being watched. The moment you come out of the browser, you will see that your inbox is full of related emails. Actually, there is a system which is monitoring your interest. So that is the velocity. Second is high frequency stock trading algorithms reflect market changes within microseconds. So gone are the days when there was a stock exchange and some changes occur there, and it was informed in the later half of the day, and we could not do much with that. So right now, what is happening? Algorithms reflect market changes within the microseconds. We have our websites reflecting all the trade that is going on the stock exchange within microseconds. Within small amount of time, we can actually see the growth or decline in the amount of the share, the price of the share. It is also because of this velocity with which the data is being emitted and it is being received at the storage space. Now the third is machine to machine processes exchange data between billions of devices. So consider the case, right? If I give input to the machine, the input to the machine is actually dependent on my speed. So in any case, my speed is not going to be more than the speed of the machine. It is the limitation of human being. I can type at certain rate. Machine process that data is definitely it is going to be high as compared to the input a human being is giving. But when it is from machine to machine, so a device generating data and device is receiving the data. So this is the velocity that I am talking about. When the rate of flow of data is very high, we can say that it is a character of big data. Then infrastructure and sensors generate massive log data in real time. Uh, Again, consider the example of traffic lights. There we have sensors. What do? They capture the real time traffic. Based on that scenario, they decide which light to lit. In case of huge traffic from one side, they signal red. When they see that the traffic is becoming little less, they signal green. So they are taking all those decisions because the data is captured there. Online gaming systems support millions of concurrent users, each producing multiple inputs per second. Now again, if we talk about online gaming system, means the user all across the world, they will be using their online games. You do not know about the location of the user from where he is logging in, but again, they all are generating data and it has to be managed. Now the third important characteristic of big data is that we need to take into consideration the variety, the type of data that is being generated from machines. Again, I am focusing on the source from where the data is being generated. It is the machine which is generating the data. Now, big data is not just about numbers, date and strings. This is traditional thing. It was, if we have to think about data, it was all about number, dates and strings. But right now, if we have to talk about big data, it is about geospatial data, that is GPS information, then 3D data, then audio, video, unstructured text, including log files and social media. You think about a case where you are posting something on the Facebook and then it is being liked by n number of friends, then it is being commented upon, it is being shared upon. Likewise, every little move that a user does on the Facebook or any social media, it is being captured somewhere, it is being recorded somewhere. So such amount of data is such type of data, actually it makes it a big data. Traditional database systems were designed to address smaller volumes of structured data, fewer updates, or a predictable, consistent data structure. So this is in contrast to the present time. Traditional database, you think about MS Access, SQL Server, and likewise, they were the database which were actually designed by keeping in mind the structured data, the data in the form of rows and columns. So during those days, there were very few updates available, and if there was a change, it would be a predictable change with the consistent data structure. But right now, what is the issue with the big data? That the 90% of the data that is being generated by the machines, it is unstructured. When things are unstructured, it is very difficult to process them, because first we have to bring them in order and then we have to process that. By this I mean, if it is a unstructured data, we have to apply certain techniques to bring into structured form, to bring the data which is unstructured into structured form, and then we can do some analysis on that, what this data is revealing. So traditional database was having the advantage of processing structured data, but the current big data, it is 85-90% unstructured. Big data analysis includes different type of data. So that is the beauty of dealing with the big data. When you have unstructured data, different type of data, our analysis will generate a heterogeneous result about the data. Why we are talking about big data? What is the purpose of actually talking about big data? Just because the data is being produced by the machines, it has to be stored somewhere. Let us suppose it is stored somewhere, it has to be processed. If it is processed, then it has to be analyzed. That is why growth of big data is needed. Increase of storage capacities. All our mobile phones, they have increased storage capacities. They have 4 GB of RAMs, and likewise external storage is also huge. Increase of processing power, availability of data. Every day we create 2.5 quintillion bytes of data. It is something beyond imagination. Just think about that. 90% of the data in the world today has been created in the last 2 years alone. So this is the point of actually the consideration that whatever data we have today, 90% of the amount, it was actually created or generated by the machines in the last 2 years. So this is called as progression of data from small amount to the colossal amount. The word here is colossal. Again, this slide, it is depicting that why we are actually big data. Facebook, it generates 10 TB of data daily. 10 TB is really huge amount of data. Twitter generates 7 TB of data daily. The fact that I have shared with you in the last slide, actually it is given by IBM, which claims that IBM claims 90% of today's stored data was generated in the just last 2 years. By this, what I am conveying, that if you see in the first top header, it is mentioning about world population in reference to the year, then connected devices in reference to the year, and connected devices per person. You think about 15 years ago, that was 2003. What was the scenario then? The total world population was 6.3 billion. Then connected devices, it was estimated around 500 million, and then connected devices per person, it was 0.08. See, such a small number of devices that was connected to per person. With the passage of time, in the year 2010, the world population, it has risen to 6.8 billion, and the connected devices, there was a huge increase in the number of connected devices. The total number is 12.5 billion, and connected devices per person is 1.84. If you go further, in the year 2015, 7.2 billion is the world population, and 25 billion, that is, it is double of 2010, and connected devices per person is 3.47. Up till now, whatever I am speaking, it was history, and in the year 2020, we are predicting this. This is actually possible because we have actually analyzed the trends, we have analyzed the data, and we have predicted. This prediction is possible because all the data generated from different sources of data generation, we have applied certain techniques, and we have concluded that in 2020 we will be having 6 world population, 50 billion connected devices, and 6.58 connected devices per person. The last column in the diagram is all the results are based on the analysis of the data that is produced before 2020. So this is what we can arrive at based on the data that we can generate the results for the future. How is big data different? We should be careful enough to actually differentiate how is this what is big data, and what is big data and what is not big data. If the data is generated by a machine, that is what I expressed before. If it is automatically generated by a machine, then yes, it is a typically an entirely new source of data. That is again big data, not designed to be friendly. This is what the third point is. All the data that is unstructured, definitely it is unfriendly. By unfriendly, it means that it is not going to be processed under a relational database system. And then the fourth point is, may not have much values. Now, data generation point examples. Mobile devices, they are generating data. Microphones, they are generating data. Reader scanners in the Walmarts, they are actually generating data. Science facilities, program softwares, social media, cameras, they all are generating data. So by this point, I have explained you what is big data. Think about a scenario where you are buying something on the Amazon. You are buying books of your interest. That Amazon is actually keeping an eye on your activity. it is actually watching your interests. You are buying some fiction books, you are buying some books related to history. So every time you are actually doing some purchase, it is actually gathering the information about you. uh, it is about one user. Likewise, uh, all the user all over the world, they are doing some activity on the internet. If it is Amazon, if it is any other net, any other site, all the users, they are doing some activity on the internet. The activity is being monitored. It is when it is being monitored, how it is going to help the Amazon people will then analyze your data. The data will then, it will be analyzed, and then the results will say that yes, uh, users in this age group, if your age group is in the group of 25 to 30, uh, from certain age in this type of, if it is a very huge number, you have made a buy, and all over the world people are doing the same thing, then what they will do with this, they will actually buy more books of the same title, because they are actually watching the trends. They will stop that particular book into their stock, and they will be ever ready to sell that book on the Amazon. So that is what happens when you use data. When you use internet, things are being monitored, and the same data will be again reused. It will be again reused for providing better results to the company as well as to the users. So that was all about big data. So why it was needed? To actually uh, read data, to analyze data, to predict the upcoming patterns. That was the reason I said it is one of the buzzword of computing industry. We should know how it is different from the normal data. If you have three characteristics, that is volume, then uh, velocity, and then the third one is variety. If these are the three things that are associated with data, definitely they will make good case for big data. Soon after possessing huge quantities, soon after storing huge quantities of data into the machines, into the system, it has to be analyzed. That is the ultimate thing. You will find that there are many occurrences where healthcare facilities are available. People are undergoing all diagnoses, all medical tests, all X-rays, all biological testings. They are they are being done at all healthcare facilities, all healthcare centers. The data is stored somewhere. It is stored at certain servers. But what is the thing which is not happening? So the data is being available, the data is stored, but it is neither processed, it is neither analyzed. So when both things do not happen on the data, it will not generate any results. If the results are not available, then it will not predict any trends, it will not give you any results. So that is the issue with the data being unprocessed. But all over the world, all IT giants, Amazon, Google, Microsoft, what they are doing, IBM, what they are doing, they are very focused on this concept. They are very focused on the generation of data from the machines. They are very particular. They are actually watching who is doing what. When they understand the uh, browsing habits of the users, they actually post all the advertisements related to their interests. You must agree with me that uh, if you have keen interest in watching sports, that is cricket, then you will get all notifications which are relevant with the sports, and in particular cricket. If you have keen interest in doing shopping, you will get all notifications related with the shopping. If you have your interest in healthcare, you will get all notification related with the same interest. It is happening just because the data produced by the machines, it was analyzed, and they produced the result that this man is actually interested in these type of things. So you get notifications according to your interests. Now, under second point, we have this cloud computing. It is also very important as far as the word cloud computing is concerned. Uh, I have a very different way of explaining what is cloud computing. You will agree with me that yes, it is an important concept, it is an upcoming thing, it is a buzzword. What is cloud computing? It is all about services and solutions. Services and solutions that are delivered and consumed in real time over internet are cloud services. When you store your photos online, use webmail or social networking site, you are using a cloud computing service. So here in this definition, the important thing is in real time. Cloud computing is a delivery model of computing services over the internet. It enables real-time development, deployment, and delivery of broad range of product, services, and solutions. There are certain characteristics that are associated with cloud computing. It will actually accomplish on-demand self-service, ubiquitous network access, that is anywhere, anytime, any device, location independent resource pooling, rapid elasticity, pay as you go. I will stop myself here and I will give you an example, which is a very general example. I have this in my mind because I wanted to actually explain what is cloud computing in a general sense. Normally, when we have our some functions at our places, what do? Uh, we actually book certain hotels, we book certain banquet halls for the job. Now, we pay for the amount of time that we have to spend there. So what we are actually doing, we are actually paying for the service that we are going to get in return against the payment that we have to make. So you think about a banquet hall that is actually charging 10 lakh rupees for 2 days. Yes, you are paying 10 lakhs for 2 days. It is giving you certain facilities. It is giving you huge parking area. It is giving you fully AC rooms. It is giving you lush green lawns. It is giving you very high quality service. It is giving you very high quality food. So all these things are actually you are receiving in return of the payment that you are making, and in this case it is about 10 lakhs. So in this one case where you are paying 10 lakhs for the services for 2 days, and uh, you are feeling very happy. Why? Because you have rented it for 2 days, and against the rent you are getting the services. You are not creating your own banquet hall for those 2 days. You are not creating all the resources. It is being created by someone else. You are just a user. So after those 2 days you will make the payment and then you will come away. So what is the point here? Cloud computing is actually it is the availability of infrastructure, it is the availability of services, it is the availability of the softwares on the internet. As a users, you have to pay for the amount of services, amount of infrastructure that you are going to use. You are not going to create your own infrastructure. So this is such a wonderful thing. Normally what happens in traditional system, all organization, they buy their own computers, they buy their own storage spaces, they buy their own technological infrastructure, and they start working with the infrastructure that they create for themselves. Now what is the situation here? What is the issue here? First they have to invest in crores of rupees for creating the infrastructure, for buying the software, for buying the hardware, for buying the services, and then they use that thing to produce the benefit. That was the old story. But right now what is happening under cloud computing? You have all these services available. You have huge infrastructure facility available. You have all softwares available. You have all hardware available, servers available. Only thing is you do not need to buy that. You have to rent it. You are going to buy the space for certain period of time according to your own need. Gone are the days when you are going to buy everything for full time. Now companies decide about the time that um, for that amount of time they buy the service, and then after consuming the services they withdraw themselves from the uh, cloud. So this is the benefit of doing or actually using cloud. We have infrastructure, we have softwares, we have hardware, technology all available on the internet. We are not going to buy it for ourselves. We are just going to use it according to our need, and we are going to pay for the services. So this is cloud. The example that I have given you about banquet hall, you will find so many banquet halls available in and around. What they all are different in respect of services that they offer. They all are different in respect of amount they charge from the user, the quality of service they offer, the reliability of service they offer. There are certain banquet hall who charge very high, but at the same time they offer you security, security of guests, security of vehicles, security of everything that you take along with you. So if they are providing you services, definitely they are going to charge more. And it is always time bound, the amount of time that you spend in the banquet hall. If you are going to book it for 5 days, they are going to charge more. For one day, they are going to charge accordingly. So we have different type of banquet halls. They ask for different rates. When they ask for different rates, it is the different type of users who go for different type of banquet halls. Likewise, on the cloud we have all infrastructure available for all type of users. If it is a small startup company, they cannot afford huge amount of resources, they do not have too much to spend, then what they will do, they will actually start their startup on a trial basis. They will ask for a small infrastructure on the cloud, they ask for a small service on the cloud just to see how their business is shaping up. If they see that yes, my business is generating benefits, then there is a point of rapid elasticity. They will ask for more processing, more computing power from the cloud. Yes, it will be made available to them the very instant, in the real time. The computing resources will be allocated to them, and thus from the same time they will start charging them more. Let us suppose the enterprise, they want to shift from one platform to another platform in terms of software and as well from in terms of hardware. Traditionally it was very difficult to do that, because for that they have to change all hardware setup and all software setup. But on cloud it is yes very much possible, because they have to generate a request wherein they have to convey that way they are shifting from one hardware platform to another hardware platform, from one software platform to another software platform, and the things will be arranged by the cloud, and they will be charging for the services provided. If there no need of buying all dedicated softwares, just connect with the cloud, all services, all upgrades will be available. You do not need to pay for every upgrade, every patch that is available on the software. All maintenance type of work, it will be done from the cloud side. We being users, we are not at all concerned with the infrastructure, we are not at all concerned with the facilities, software facilities, hardware facilities. We have to spend our mind only on using the infrastructure. Same, it goes very relevant with the example that I have given you, banquet hall. When you visit any banquet hall, you are not at all concerned with the whitewash of the banquet hall. You are not at all concerned with the maintenance of the banquet hall. You are paying for 2-3 days. You enjoy there, and then you come back, and then you withdraw yourself from the cloud. Then few more people come there, they use their services, they pay them. So cloud is actually something very big. They provide all sort of services to the user, let it be computing services, let it be services with respect to the platform, that is hardware and software, and let it be services with respect to the infrastructure. So these characteristics, the first one, on demand self service, matlab you are asking for a service and you are getting it, you access it anywhere, anytime, any device. Had it been a traditional setup, you are working in a company, all your servers, it can be accessed only when you are in an office. So that is not possible these days. If you have to work from anywhere, anytime, on any device, it is only possible if you are connected, if your organization is connected with some cloud. Then again, location independent resource pooling. Let us suppose I am working on a cloud, I keep on shifting my location from one place to another, and at certain point of time I realize that I need more computing resources, and I am at a very different location from my usual location. Again I will ask for again I will ask for resource pooling, and it will be done very promptly. Then rapid elasticity, the same thing, and pay as you go. If you want to withdraw, if you want to withdraw the resources, if you generate a request, the same will be withdrawn very easily, and you have to pay accordingly. That is what it is called as pay as you go. So this is what I have explained, software as a service. We get this service, then we get platform as a service. Google's App Engine is example of platform as a service. Then infrastructure as a service, data centers, servers. Conclusion: cloud computing is evolved by consolidating several technologies like software as a service, grid as a service, and virtualization. Major three services are software as a service, platform as a service, and infrastructure as a service. Now there are three deployment models: private, public, and hybrid. Now in the last segment of my presentation, I have actually decided to talk a little bit about smart cities. The word smart is actually synonymous to something which is very efficient. Efficient is something which is always explained in relation to time. So smart cities, they are going to help the citizens in actually getting all those services which we are getting traditionally, but this time we are going to get all those services by keeping time into consideration. What we are getting earlier, also we are getting certain services like asking for a water connection, asking for a electricity connection, asking for a healthcare checkup. Every time all those things we were getting in the history also, but now in the future we are going to get same services, but keeping one constraint along with it is time, the time taken by a citizen to actually avail a service. If the time is less, actually we are actually proceeding toward smart cities. Smart cities, I want to actually come clear on this, that smart cities, it is not only about big buildings, majestic buildings, huge roads, huge transport systems, huge bridges, huge towers, uh, great lush green parks, uh, glass glass buildings. No, smart cities, it is not like that. Yes, it will make cities look better, but smart cities are actually giving same set of old services in an efficient manner to your citizens. According to definition, a smart city is an urban development vision to integrate multiple ICTs and Internet of Things solutions in a secure fashion to manage a city's assets. So it is talking about how to manage cities' assets. So we have to come clear on what are cities' assets. They are local departments. As we have our departments, we have health department, we have transport department, we have power department, we have civil department, we have education department, we have information systems, schools, libraries, transportation systems, hospitals, power plants, water supply networks, waste management, law enforcement, and other community services. So what they are? They all are cities' assets. The goal of building a smart city is to improve quality of life by using urban informatics and technology to improve the efficiency of services and meet residents' needs. So this is very critical here to understand that the goal of smart city is to provide all those services but efficiently. ICT allows city officials to interact directly with the community and the city infrastructure, and to monitor what is happening in the city, how the city is evolving, and how to enable a better quality of life. Through the use of sensors integrated with real-time monitoring systems, data are collected from citizens and devices, then processed and analyzed. The information and knowledge gathered are key to tackling inefficiency. Now there is another definition about smart city. As world urbanization continues to grow and the total population expected to double by 2050, there exists an increased demand for intelligent, sustainable environments that reduce environmental impact and offer citizens a high quality life. A smart city brings together technology, government, and society to enable the following characteristics. Definitely, it will help in generating a smart economy, smart mobility, a smart environment, smart people, smart living, smart governance. We are going to get these benefits. It will help in making our life better, higher levels of transparency, and it will definitely bring openness, efficient resource utilization. So smart city framework, services framework, these all services are going to be interconnected with each other if we are actually thinking in terms of developing smart cities. E-governance, transport, logistics, public safety, governance of urban infrastructure, uh, energy and resource management, environmental protection, climate change adaptation, community and household healthcare. These all have to be integrated so that we can get maximum benefit of each service from the government. So at the end, in order to conclude this session, earlier it was big data, then it was cloud computing, and later on it was followed by